welcome back to Algebra 1. Today our goal is to continue working with our power rules and how we simplify expressions using those power rules. So far we've added in two power rules. One that deals with what's called the product of a power. Now, yesterday I got this question a little bit. Do I have to have that title memorized? I said, you don't have to memorize the title, but the title does give me a little description of what's happening in the problem. Right, I have a multiplication problem that includes powers, so my rule would then be to add things up. So it's just kind of a visual reminder or a vocabulary reminder of what's happening in our rule. I'm not going to be giving you this definition being asked for that word that goes along with it. All right, so in this case, if our operation between our bases is multiplication, and our big number called our base match, then we can take all those and put them together by adding up their exponents. All right, so again, in between here, this has to be times, and these bases have to match. When that's the case, I'm multiplying the same base, I can add up the exponent. All right, rule number 2, it's called a power of a power. Again, it kind of tells me what's going on. I have an exponent that also has an exponent, and in that case, I actually multiply to get the simplified version. So you have to be careful. These two rules, we tend to get mixed up. Right? For the first one, sometimes we accidentally multiply instead of add. And for this one, we sometimes add up our exponents instead of multiplying. So just be careful. A little number that has a little number, we have to times those. All my bases are the same with exponents. I have to add them up. So our goal for today is to add in rule number 3, which is a power of a product. Power of a product. Again, the vocab kind of helps me here, because I'm going to have a power that's on an item that is all multiplication. Right? So I have a power on something that's all multiplication. How do I go about simplifying? All right, so this is how it works. I have one big grouped item that inside of there is all multiplication. So I put the dot here just as a reminder, but remember, those could have been side by side, which represents that those two things are being multiplied. When that's the case, this exponent can get handed out or sort of distributed in a way to everything that's on the inside. So this would get shared to the A factor in here, and this would get shared to the B factor. But you have to be careful, because inside of our parentheses or a group, it has to be a product or a multiply. It can't be an add, it can't be a subtract, right? It has to be a multiply, so be careful. All right, and we'd end up with something that looks like this, where each individual item now has that power. If there's nothing else I can do to simplify, we'd write it the best way possible. A to the m, in this case, b to the n. Now, normally, m's will be a exponent number or value. So let's look at one more. All right, we have a 2 times 3 to the 6th power. All right, so inside of here, again, is a multiply or a product, right? Product is just a fancy way of saying you're going to have a multiplication problem, which means I can take this exponent and share it to the 2 and share it to the 3, which would result in something that looks like this. 2 to the 6 times 3 to the 6. All right, so starting today, we're going to look at, I want to evaluate, right? I want to evaluate those powers. All right, so this 2 to the 6th power would give us a 64. And this 3 to the 6 would give us a 724. And I can multiply that all out, and our simplified version of 2 times 3 to the 6 would give us this entire thing of 46,656. All right, number 3, a 6 times 5 all to the 2nd. Since inside of here is multiplication, that means we could take our power or exponent and share it to the items on the inside. Right? So this 2 can go here to the 6, and it can go here to the 5. And we now have a 6 squared times 5 squared. Now, if we were leaving our items as powers, we would be done. If we were evaluating all the way, we could keep going. We'd say, oh, I could do the math there. 6 squared would give us a 36, and a 5 squared would give us a 25. So we can say, all right, now we just have two numbers we can multiply together and see what we get. In this case, we would end up with a 900. All right, number 4, 4yz to the 5th power. All right, now, when I look at this, I sort of see one item on the inside, but remember, this is a 4, a hidden operation multiplication, a y, a hidden operation multiplication, and a z. Since in there is one big product of multiplication, that means I could take the exponent and share it to those items on the inside. So this 5 is going to go to the 4, it's going to go to this y, and it's also going to go to the z. It goes to every individual part of that multiplication problem. Right, so we have a 4 to the 5th times a y to the 5th times a z to the 5th. And then we would go and say, can we keep going with anything? In this case, z to the 5th, we're stuck with that. Right, y to the 5th we're stuck with, but 4 to the 5th we could write better. We could evaluate that. So 4 times 4 times 4 times 4 times 4, or use your up caret button. 4 to the 5th will give us a 1,024, y to the 5th, z to the 5th. And we want to smush it all back together to get our final simplified version. Now, would it be okay if I had 1,024 z to the 5th, y to the 5th? Absolutely. Remember, commutative property of multiplication. I can move my things around in multiplication and get the same result. So these two could be flipped, but they have to have the exponents of 5 attached to them. All right, a 3 times a, that whole thing to the 3rd power. All right, inside of there we have a product because these two things are being multiplied. Remember, we can't have add, we can't have subtract inside of there. It has to be times for this rule to work. So since this is times, we can take this 3 and share it to these items on the inside. And when we do that, we end up with a 3 to the 3rd times an a to the 3rd. All right, this a to the 3rd, we're stuck with it. There's nothing else we could do with it. But this 3 to the 3rd, we could evaluate further. So use your little up caret button on your calculator, or do a 3 times 3 times 3. And we'll end up here with a 27, still times an a to the 3rd power. All right, last one, number 6. All right, negative 2w to the 2nd. There's quite a bit going on here, so we got to kind of break it down piece by piece. First is this negative sign, and the fact that it's touching a parenthesis implies that there's a multiplication outside here. And more importantly, with this negative 1. All right, so I would start there and say the negative is really showing me a negative 1 times. And then we have this product here of 2 times w that has this power of 2. Here's where you need to be careful. The negative 1 is outside. It's not part of that product inside the parentheses. So it has nothing to do with that power of 2. Right? It's its own individual thing of negative 1 and technically has an exponent of 1. Right? This is just negative 1 to the 1st power. It's just this 2 times w that has this exponent of 2. So this 2 goes to this 2, and it goes to this w, but it does not go to that negative 1 on the outside, so be careful. So we end up with negative 1, a times, a 2 to the 2nd, times a w to the 2nd. And then we want to simplify anything else that we could simplify. So this 2 squared would just give us a 4. And a 4 here, right, negative 1 times 4 times w squared is what we would now have as our next step. And we could take the negative 1 and multiply it with this 4, right? Those are two numbers. We could just put them together. So negative 1 times 4 would give us a negative 4, still times a w squared. And we've taken that and we squished it down to its most simplified version. All right, so let's go to our study guide. Let's fill in our rule number 3. All right, 2 times k times m to the 2nd. We're going to take this. This is all multiplying here, so we can share to all 3. And we get a 2 squared times k squared times an m squared, which when we put it all together in its most simplified version would give us a 4 times k squared times m squared. All right, I hope that helps you attack your work for you today. See you guys later.